Good morning, good afternoon, and good evening, wherever you are. And welcome to the 11th of our 12 days Geospatial Python Bootcamp. Today we will look at image classification. And today will be specifically for unsupervised classification using Python. I wanted to do the two today, but time may not really permit us because the supervised requires a lot of steps from the picking of the training samples and all. So we'll do unsupervised today, wherever that will, whenever we will finish that one, we will end the session for today. And then we will dedicate the whole of tomorrow for the supervised classification. Okay, so let me get to full screen and then let's start the task for today. Inside my day 11 folder, I have my file there and I have the datasets folder here. It contains the files that we used yesterday for the spectral indices. If I come to QGIS and open my day 11 data set, it's just the bands, the cropped bands that we used for yesterday's spectral indices that I'm using the same thing for the classification today. So you can just copy that data over, or if you have your own data, in your case, you can fix it in place wherever I have my own data fixed. Okay. So we need a few imports here. Let me import them. Now, let me select a kernel first. And we will import raster rule as real. We will also import numpy as np. Let me import os at the top. We need it to import os. It is not compulsory to put it at the top, but I think it's recommended that if you are importing the default packages that come with Python, you do so at the top, and then other packages can come in. That is why I'm importing OS at the top, but you can import it at the last and nothing will happen. After NumPy, we also need from sklearn. Did we install this? Yes. From sklearn.cluster, we want to import k-means. We'll be using k-means for that. And so if you don't have this sklearn, which is also scikit-learn, I don't recall whether we went over the installation during the onboarding, but install. Maybe I'll say conda install, just so that to take me to how I'll install that one. So their own page here. Okay, they have different methods of installing it, but we will choose the conda. We will not create a new environment here. What we will do is this particular line of code, what it will do is that it will create a new environment called sklearn env, and then it will install the scikit-learn for you. But I think we can easily do conda install scikit-learn, and then that will install it for us. So you can come to your terminal. If you're on Windows, you have to search for the Anaconda prompt, which should bring up what we call the Anaconda, maybe an Anaconda terminal or a prompt, something like that. When you see something like that, you just pick it up. But I am streaming from a Linux environment, so what I can do is I'll just say conda so that okay, so let me just say conda activate geospatial. I think there's one called GeoPython, the one that was having a problem with the Fiona stuff. So now if I have my environment activated like this, so if I do conda install and then I install scikit-learn like that, when I press enter, it will go through the processes. I think it is having problem with my internet or something like that. But it's that I started the installation process. It will now ask me to accept some stuff, and then it will do the installation for me. Okay. Okay, saying that all requested packages are installed. But in your case, if you don't have it, it will install it for you. In case it says that enable your, like, sometimes it will just say Y, sometimes all these packages will be installed, Y or N. Just maybe press enter or type Y and press enter. Each of them will work. And then you have scikit-learn installed like that. So let me just deactivate this one, conda deactivate. And then even close my terminal. So when you do that, you can do this import on this line. And then after k-means, we will also need matplotlib, which we already have. So import matplotlib .pyplot. We are looking for the pyplot manager as PLT. Let's just import it in case we need to use any the pyplot, then we don't have to now import it again. Today is unsupervised, and we will not be assigning any training samples, so we will not need GeoPandas to read any data like that, any vector data. So now this is imported. The next thing to do is to read the bands using raster. So all the bands that we are now using for the classification, we have to read all of them. And so what I will do is to declare the images directory. So images directory, like we always do. And this will be os.path. Okay, I just wanted to make it a bit more technical, but let me just keep it simple. That will be ./dataset. The datasets or datasets. And then what we can do is we can say that the band parts, or maybe the band names, should we do it that way? I'm thinking whether we should get the names first or we should get the path. Okay, so band underscore path. I'll break this one on separate lines. So now I'll say item for item in os.list directory. We have been seeing this so many times. os.list directory. And then which directory do we want to list? We want to list the images directory. And let's be safe and say if item, dot ends with, and then we say, I think it's dot uppercase TIF, maybe something like that. Let me check. Because you're not very if you're not very exact here, it will throw errors. Okay, the TIF is uppercase. But what I want to do here, this one will only return if I print out band parts. It will only return band 2, the names like that. But what I want to do is to, why doesn't it sort this? what I want to do is to get the full path, maybe data set slash then band2, because we need a full path to be able to open it in raster. So I'll modify this statement a bit. That's why I think I even brought it to the next line. I don't know whether this will work if I have it on the next line. Okay, it works. So item for item in this, what I'll do is rather to say, I'll get this item up and say os.path.join, and then I will join images directory with a particular item. And then let me even bring this to the next line so that I can explain it well. So what I'm doing here is that for each of the items inside the images directory, I'm joining the item name. You know that the item is just the raw names of the files like we saw or we see in our console here printed out. So I want to get the full path so that to be like slash dataset slash b3 slash dataset slash b6 and all that. So that is what this line is doing for me. It's taking it, each of the items, and joining it to this path for me. And then I'm doing that for all the items in this images directory, which this guy will list here for me. And I want to put this safe code here that in case other files come to join themselves, or sometimes .xml and other files are created while we are using rasters. In case there's something like that, just fetch out the TIFF files for me, because those other files, raster doesn't really need them when we are doing GeoTIFF operations. It will use them, all right, but it doesn't need us to probably call them explicitly. Okay, so with this modification, when I run, I'll see that now it's dataset slash b3 and all this one. So these are the ones that we can read. So now what we want to do is to, and now we've read the file. Let me give comments here. So maybe get band paths. And then this place, what we will do is we will read the bands. Okay, we'll read all the bands and put it in a single list. So read the bands. Okay. Then now say for band, or for maybe for band in band parts. What I want to do is to say with real.open, and then I want to open that particular band. Is this even a band? I don't think it's a band. Maybe I should say for file. And I want to open the file and maybe as src. And then after that, I can, let's create a list here to store all the bands. So we can say bands now equal to an empty list. And then here, there are two ways we can read the band first and then append it to the list. But I want to do that straightforward. We can just say that maybe band underscore equal to src.read, and then we read the first. It's a single band raster, so read the first one. And then now do bands.append. And then we append the band underscore. I'm just adding the underscore at the end of the name because, okay, maybe I didn't have to do that. I can even take it off. I thought there was another file there called band. That's why I added the underscore. You can do it this way. It will work. But the other way also is to just say bands.append, appending it directly. And I want to append src.read the first band. So what this one will do is it will go through all of them, read it, and then append it there for us. So if we inspect what is inside our bands now, we see that there's a couple of raster data sets in there. We are seeing zeros because the edges are not really the way we cropped it. The objects are used to crop. It's not really a perfect square. So there are some edges at the top left, especially that are 0. They are no data. Remember yesterday, I set my no data values as 0. So that is what is happening here. The zeros you see, that is the meaning. There are no data values. Okay, but I think it's the variable explorer that will help us to see it well. So if we come into bands, okay, still I thought it will give them to us as raster array data sets. Okay, the bands are already numpy arrays, so that is why we should see them as those matrices. The next step is to stack the bands into a 3D array. Currently, it's just XY 2D. So each of the bands inside here is just in its own 2D. So it has X and Y. But now we want to stack everything, all of them together as one. And then so that now it will be the X's and Y's of all of them plus the Z part or the number of bands we can say. So if we are stacking 3 bands, it should be the number of rows and columns now by the number of bands, which is 3. So if we, let's say if each of the bands in there has 100 rows and then 200 columns, that is the dimension. So it's 100 by 200 and there's no third dimension because it is just that flat. But or if you want to say it, you can say that it has only one. So 100 by 200 by 1. But you wouldn't really say that the one is, you don't really say the one. So now what we want to do is to convert all the arrays into a 3D one so that we now have, let's say, the 100 by the 200 by the number of bands that we have. So the row, the column by the number of bands. And so that will also happen here. But we need to stack all of them together and then perform the classification on the stacked band. Stack bands together into a 3D array, which is like a row, column, and then number of bands. Let me scroll up a bit so that you see. So we can name it stacked bands. That should be equal to np.stack. You remember we imported it at the top there. This we use the d stack, and then that one I think by default stacks it. What is the default? If you have, there's a default parameter in here. Okay, so this is what I'm looking. That's why we are using this stack. This is because it's instead of just stack. This one stacks the arrays in sequence depth wise. So along the third axis. Yeah. So with this kind of thing that we are doing, we just have to stack it along the third axis. If I'm not being very technical with the stacking along the third axis, just take it like we want to just put it on top of each other, like how you have pieces of sliced bread, or maybe use that one to make some sandwich. You just put it on top of each other along the z-axis, so let me just say vertically. Yeah, we are stacking it like that. So we just put the one down, the one on top, the one on top, the other on top, just like that. So that is how we are doing it. Yeah, the D stack will help us to do in a very non-technical way. So what we want to stack then, we want to stack the bands because we have already read them in the, so they are now in a numpy array. So we want to stack the bands. And then now we can, let's inspect our stacked bands. It will now become one very big array. Let me, now you see that it's only one array, but it has all of them inside there. So if we now do the dot shape, let me see. That means that in each of the bands that we stacked, we had 1,014 rows, 1,398 columns, and then there are 8 bands. If you check the folder, you see that there were 8 bands in there. Band 1, 2, 3, 4, 5, up to 7, and then 10. So there are 8 in there. Okay, so our stacking along the how does it name it here technically? So along the depth-wise or the third axis was successful. But these values, we need them. So what I'll do is to now say that maybe n rows for number of rows, n calls, okay, n underscore columns for number of columns, and then this one will be n bands for number of bands. That should be equal to stack bands.shape, because it returns a tuple of 3 things, so we can access each of them here into this particular variable. Now let's go ahead, and then we have it in 3D, but now we have to reshape it. Yes, before we can apply the k-means. Yes. Maybe if you're wondering why we are doing the reshaping. Well, usually if you want to perform classification, you have your labels, and then how do I put it? So you use one thing to predict another. So having 3 levels in there or 3 dimensions in there, maybe there's a way you can go about it and then do some subset. I don't really know how that one will be done, but it is best if we reshape it to a 2D array, so that instead of having rows and columns and bands, we only have pixels and number of bands, and then we deal with the pixels individually. That will make our life way simpler than having to now deal with rows, columns, and bands. That will be a bit tough. Okay, so let us now reshape this one. So reshape to a 2D array, and that will be so that we can get pixels and the number of bands. Number of bands. Okay, so that's going to be our reshaped bands, something like that, and that should be equal to stacked bands dot reshape, and then in here we have to pass -1 and then the number of bands. Okay, let me look at. So if we reshape our if we try our reshape bands here, okay, reshape bands. Let me see dot shape. See that now, instead of having to deal with maybe what was the number? Maybe they were all above, I think, 1,000. Go over them row, column. That will even take a lot of time. And now we have just, should I say, flattened or condensed it into just a 2D array with no data lost. All that is doing is that it has now put them all together. If I should be less technical, it has flattened them into one big or one long array of just pixels. We are not dealing with rows and columns here, so we shouldn't even keep track of them. So we just call it, and then it runs on all the pixels for the 8 bands here. Okay. So now that this is reshaped and easier to work with, we can apply our k-means, which I want to do it in a new cell. So let me put a mark down here and say apply k-means clustering. So I'll name it k-means. There are other ones that you can use, but this k-means that's fine. That's fine. So the k-means we imported at the top there. And we have to specify the number of clusters, which is also the number of classes. So we can say n clusters. If I choose 4 for my number of classes, there are other things that we can pass in there. So let's see. So we have maximum iterations. There are 300. The tolerance, is it? This is the tolerance. Let me go down and see. TOL. Okay, that's the tolerance. What I was looking for is the random state. So it determines the random number generation for a centered initialization. When you are looking for less technical definitions, and then you see technical stuff. So just look at it like this way. So it is an integer value that is used to make the randomness of this classifier deterministic. So it's just something that is supposed to make our randomness more random, so that we try to eliminate any kind of bias and all those things. So we make our selection and all the process like so random as we can. And so let's just put a random state of 0. What is the okay? Initially it is none, but usually put it at let's put it at 0, and then we leave the rest as it is. It's just that fine. And so this is the classifier. It has been defined, and so the next thing that we have to do is to fit the classifier. Those are more like machine learning terms. K means dot fit, and then what do we want to fit it with a reshaped bands. And so this will, okay, we are not doing machine learning here, but I think I still have to explain some stuff. So the fit, all that the fit will do is to compute the k-means clustering. So it will just be passing all our pixels. You know that we have reshaped it into pixels, so it will be easy for the classifier to work with it. It just takes pixel 1, work with it, go to pixel 2 and all that, instead of having to go around rows and columns and then depth or number of bands, and we ourselves making sure that the loop is well structured. All of them has been fixed with the reshape. So we just pass it to k-means, and then k-means will cluster it for us. So it will classify it for us. Let me just say so. Okay. The other things that you can pass in here, we have done the array, and you can put a sample weight there. You can read on these things if you come to scikit-learn website. If you really want to go into it and understand these things and how they work, I think when you come here, you can search for maybe k-means. And you see this scikit-learn.cluster.k-means, that is what we imported. So you can read about it here. I think this is for the documentation, but they had I think, let me see this one. Okay, it's still the same, but if you want to read about it, you can come here and read about all these parameters and what they do. Okay. So it even tells you the particular algorithm that is behind the scene and all that. So there are a lot of it you can read from here. And so now we fit our classifier. Let us get the labels that will come from it. So let's see what the output of the fit even is first. Okay, it outputs a k-means object. So from that k-means object, we can get the labels, which is our classified image, or our classified pixels or something like that. So what has been classified. So the output of the k-means fit is that it will perform the clustering for us. And then from that cluster that will be returned, we can now get our labels, which we can further reshape and get our image. Okay. So let me go classified. And sometimes it's a bit difficult for me to find non-technical terms to explain stuff, but I just hope that my explanations are not too technical so that you understand. That is my goal here, for you to understand every line of code So if you have to modify it on your own, it will not be difficult. So that k-means dot labels. This one will be returned. And then we now have to reshape this label to original dimensions of rows and columns. Remember our raster, before we write the raster, you have to write it in rows and columns. That's why there's width and height in the metadata. So this our reshaped bands that we have made it into a 2D. That is only the total number of pixels and the bands. This is why we cannot just write this one, an array of this type. You cannot write it easily like that into a raster TIFF file or something like that. So, but that is what is good for the k-means cluster or k-means classifier. So let us now reshape our output from its dimension to rows and columns so that we can save it. So now that would be, maybe let me put a comment here. Reshape back to original dimensions, and those ones are just rows and column. Remember that this output will just be one image. The classified will just be one image. That is why we are not reshaping it back to, we are not adding number of bands here. We will not reshape it this way. We only reshape it to rows and column because we are only writing one image. Okay. And so that will be, let's call it classified image. And then set that one to classified dot reshape. Reshape is here. And I want to reshape it to, remember these variables that we extracted here. So let's say if we have an array that looks like this, and we tell NumPy to reshape it. So this number is even that huge. So let's say we have an array of 20, and we want to reshape it to a size of maybe 4 and then 5. 4 rows. So would that be 4 rows, 5 columns, or maybe 5 columns, 4 rows rather? So that means we have to pass in the number of rows and columns here, and it will look at the number of pixels that we have and then break it down to rows and columns. So if there are 20 and you want maybe 4 rows, 5 columns, it will use that one to break the 20 values into 4 rows and 5 columns, like that. So we want to now reshape that into the number of rows and columns that we had in our original band. So this is all that we have to do actually. So let me run this. I'm hoping that will not take a lot of time. This is all that is happening, the classification. Okay, it is done. So before we can see this image, we have to write it. So let's just write the image into a file, and then we now can visualize it. And so you know that before we can write into a file, we need some metadata. So let me come here. Select this one and copy the entire part. I just want to read it and then get the metadata. That's all. So that will be, this step is saving classified raster. And I can say band 1. This is band 1. So with real.open band 1 as SRC meta or metadata. Let's just say meta equal to src.meta. Okay. And we don't really need to change any metadata here because okay, the count is already 1. Are you okay? Let's print the meta and see. So meta. And let's just see so that if you have to modify anything, modify it. Our driver is gtif. Our data type is integer 16. Maybe we can leave it like that. The count is 1 and all this one. So let's just leave it like this. We will not modify anything. Okay. And so now that we have our metadata, we can save our NumPy array. And we can go. Did we just check the classified? Okay, so let me do something here. Let's check the classified image dot shape. I want to see the shape, the reshaping. Okay, it was successful. Let me delete this cell. I just wanted to check the reshaping. Now I can save it with okay, let me give a comment before save classified or save the image with real.open, and let me define the classified part. So that will be okay. I'll just call it classified in the same folder, no problem. That is the only output to be generating today, so we can keep it there and it will not be a problem. And I'll say ./classified .tiff. I want to open it in write mode, and I want to also spread the metadata. So meta as dst, and now I can say dst dot write, and then I write the classified image. Make sure that the band is 1. I'm writing a single band raster. So let's just hope that we did not do anything wrong. And so we inspect our folder, and then we have a file here called classified.tiff. Let's first visualize it here before we visualize it further in QGIS. So visualize classified raster. And so that'll be plt.imshow. And then you can say classified image. We can provide a color map. I will leave it default for now. And then maybe say plt.title. And then let's say unsupervised. K means classification. And before we can see anything by this plotting manager, we just have to say plt.show. Okay, so let's see how good our classification was. Okay, so this is it. You can see from, I don't know whether is that visible on your screens. Do I have questions? Where did we exactly mention the labels of the 4 classes to the k-means classifier? Oh, I did it here. N clusters. The N clusters are the number of classes that you want to generate. So those were the ones I just said 4. Okay. So this is the output of our classification. Let's go to QGIS and then drag it in and see the 11. Okay, usually it will come in like this, but you can go to classified, the properties, to symbology, then we change it from single bound to paletted or unique values. Here we can choose the classification, and then if I choose Viridis, apply. Okay, apply, okay. I don't really think I like this. Okay, there's some form of this no data values. were also classified as part of our data set. So it looks like it's assigned a value for all of them. Okay, but we can still see that the classification has done a good job. I think the number of classes is what? Why 3 here? Because I only see 1, 2, 3. Or there's not enough. Okay, but even in that case, you should be able to still give us the 4 classes. What is wrong with our code? But we can see here that at least we have it gives us an idea that there is something here, which of course we know that is the water body Lake Bosomchi. And it has really done well by, you can see that it has really been able to really classify the lake. I don't know if you can see it on your screens, but there are also some small patches of this color blue here, which represents the water. And I may be expecting some at these places too. Most likely the yellow is the vegetation, and the white areas may be built up areas. Yes, so I think some of the places that it was not able to maybe really classify was the maybe bare land or other land cover types that did not really pick out from the image. But we can see that it has done a good job. And let me come back to our code. Okay, let me just say something here. np.unique and then classified image. But inside that array, there are 4 classes. So why the 0 is not? Why is it not giving the 0 a color there? Okay. Okay. Thank you. Someone is suggesting I change the number in the symbology window, because you can see when I inspected that it should give me the unique values inside my classified image. I can see here that I have 4 classes labeled as 0, 1, 2, and 3. So let me go into the symbology and then change it. Where would that one be? Okay, my friend who suggested it. Okay, where would that one be? Yeah, okay. I don't really use QGIS for this kind of stuff. There are things I use QGIS for. I really use Python and Esri products. So I like QGIS. I use it because it's fast. You don't have to really create a project before you do something. And also because it is open source, it has access to, if you look at your left side here in the processing toolbox, you'll see GDAL here. So it's able to work with a GDAL like that. So I like it, especially when I'm doing those kind of raster analysis. Yeah, but as to where to change the number of classes in this one, I don't think I can do that. If I add a new class here, no, that will not solve it. It's just okay. But I think Python told us that there are 4 classes in there. If you know how to bring out the 4th one here, you can do that at your end. The white zones, no, not okay. Yes, you've drawn my attention to it. I think that is the 4th class. Yes, because we actually have 4 colors here showing in our image. This one that looks like maybe some kind of indigo or whatever color, purple, I don't really know. The white, the yellow, and then this particular blue color. But if that's the case, okay, or is it because the other one starts with 0, it doesn't really want to label the 0? I think so. But that is not the point of this tutorial, to make sure and force QGIS to show us the 4th class. It was to teach you how to perform unsupervised classification using Python, and I think that part is done. So please let me know if you have any questions that I have to address on air. Other than that, we will close chapter on today, and then we will anticipate for tomorrow where we will do supervised classification. Okay, so we have 4 classes as we specified: the purple, or is it violet, or whatever color, the white, the yellow, and the blue. Okay. I couldn't really crop it to a perfect rectangle, so that part is also being classified. The 0 part, I don't really think it's a good thing, but that no data shouldn't have been classified. But since it's 0, and the other ones are here, usually you not really use unsupervised classification for any kind of serious analysis. Maybe it's just to give you an idea of what is there or something like that. But when we are doing the supervised classification, that's when we take charge a lot, and we take charge and really define what should happen when the classification is going on, other than just sitting down and then waiting for the computer to do it for you in this unsupervised case. So I don't think there are questions. So that should bring us to the end of today's stream. Okay, so thank you once again for joining. It has been a wonderful day as always. And so make sure you keep on practicing these things. That's the only way you can understand it and be good in it. So have a great day, all of you who are still in the day, and have a good night, those of us who have to retire to bed. Until next time, it is goodbye.